Okay, 7.3, triangle similarity. Okay, so we have done triangle congruency before, yes? Okay, so we had side, 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 angle, side, angle, angle, side, correct? So you're going to have 3 similarities. Now, what it means to be similar is angles are congruent, sides are proportional. Okay? Congruent means they're the same measure, correct? But proportional means they can be 1/3 or 3/4 the same size or twice the size. Got it? So they're not, the side lengths aren't equal, but they are proportional. So we have angle, angle similarity. Now look at how we abbreviate it. What symbol do you think says similarity? The squiggly. And that's actually called a tilde, just so you know, back when they made us learn those names. When we read that, we say angle, angle similarity. That's what the AA tilde says. Okay? So they're not congruent, but they're similar. So that means the angles are congruent, the side lengths are proportional. Got it? So it says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Now, they could be congruent triangles, but we know they're at least similar. Got it? So if I look down on my picture, I have angle A is congruent to angle D, angle B is congruent to angle E because they match the number of arcs, correct? So that tells me those 2 triangles are similar, but it also tells me that A, B, B, C, and AC are proportional to, so I have AB is here, yes? So what corresponds to AB in the other triangle?
DF? No, DE.
DE. So DE comes here. Okay. What corresponds to BC? EF. And what corresponds to AC? DF. So that's called the extended ratios. Remember when we had the extended ratios the first day? So this was triangle ABC, or all the way across the top, and then triangle DEF, or all across the bottom. So if these are similar, all of these ratios would be the same. They'd be 1/2, 1/2, 1/2. 7/8, 7/8, 7/8. Make sense?
Yeah.
So before, when we were doing ratios, you usually put like the one shape in the first. Could I reciprocate these if I wanted to? Could I reciprocate them? Yes. The only thing I couldn't do is I couldn't do the triangles down because there's 3 of them. It wouldn't work. Does that make sense? So the next one is side, side, side similarity. So my abbreviation is SSS, and then your squiggly, your tilde. So it says if the corresponding sides of 2 triangles are proportional, so the ratios all reduce to the same thing. That's what proportional means, right? Then the 2 triangles are similar. So they have it set up like we just did. This top is triangle ABC. and the bottom is triangle DEF, and that's a horrible triangle. And again, what does this symbol right here mean? Similar. Because congruent was what? That?
Equal side with tilde.
Right, equal side with the tilde. Okay, the last definition we have is side. Oops, I touched it without putting on my pen. Side, angle, side. What does it say? But what is it? What word do I say? Side, angle, side, similarity. Got it? So when you see that, you just say side, angle, side, similarity. So if if an angle of one triangle is congruent, because remember, angles have to be congruent, sides have to be proportional, right? So if an angle of one triangle is congruent to an angle of a second triangle, and the sides that are included, now what does it mean to be included? It means the sides that make that angle, right? Okay. The sides that include the two angles are proportional. Then the two triangles are similar. All of these statements work the other way also. Okay? If they're similar, this is what happens. Got it? Okay, so those are our definitions we're going to use to do our examples on the next page. Okay, it says, are the triangles, I don't know. Are triangle ABC and DEF similar? So which similarity rule would we be using for these? Side similarity, right? Because we have no angles. So in our top, we're going to put triangle ABC, and then we're going to put over triangle DEF. So the easiest way to do it is to draw all this out first and then do triangle ABC. I would just go 3, 4, 5. Doesn't matter where I put those. Okay? Make sense? Now we have to put corresponding parts. Now remember, our rule says the shortest side is across from the smallest angle, the longest side is across from the largest angle, like that, correct? So when I'm saying corresponding, if these are similar, the shortest side has to correspond with the what? Shortest side, correct? Okay, so what does 3 correspond to? 4.5. What does 4 correspond to? 6. What does 5 correspond to? 7.5. If these do not all reduce to the same number, then these are not similar, are they? You can't move these around. Shortest to shortest, longest to longest, medium to medium. Got me? Okay, I'm going to multiply everything by 10. Why? Well, I'm going to multiply this by 10 and this by 10.
To get rid of the decimal.
All right, to get rid of the decimal. So this makes this 30 over 45?
Yeah.
Mm-hmm.
Okay, what is 30 over 5 reduced to?
Wait, 30 over 45?
Mm-hmm.
3 and 4. Or, 2 and 3.
How about 2 and 3? Because 15?
Yeah.
Yeah? 4/6. 2/3. And this is going to be 50 over 75?
2/3.
2/3. So are they similar?
Yes.
Yes. Okay, there's work. All my explanation is there, correct? Okay, if one of those came out to be 4/5, are they similar?
No.
No. Questions? Okay, are the triangles PQS and RQP similar? Now, in this picture, how many triangles do you see?
2, 3.
3. Because we have this triangle. Yes? We have this triangle. And then we have the whole thing. So we got lots, right? So we need to know which ones we are talking about. So, PQS, so triangle PQS and triangle RQP. So, PQS, that's the whole triangle, isn't it? Okay. So what are that's the whole triangle. And then RQP is what?
Just
Like
like
a little under half.
Like this one right here? Okay, so what rule do we have here?
Angle. No.
We don't have side, 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 do we?
no.
No.
Side angle side.
We have side, angle, side because what angle is included in both of those triangles? Q. And not changed, right? Q is exactly the same in both triangles. Where up here, this P is cut, right? And S isn't even in the other triangle, is it?
No.
Okay, so we're going to be using side, angle, side. So PQS. So what are the two sides I have in PQS?
18.
I have 18 and
27.
27. Okay, how did I get 27? You had to add those two together, right? Okay, so now, remember 27 is the long side, yes?
Yeah.
And 18 is the short. So what corresponds to 18 in RQP? 12. Why not 18?
Because that's the long side.
That's the long side, right? Okay, so then this is 18 over here. Okay, don't think just because it has to be 18 over 18, right? It could be, but it doesn't have to be, does it? Okay, 18 and 12, do they reduce?
Yeah.
To what?
3 over 6. Oh, wait.
6.
So what, 3 over 2?
Yeah.
Now, I could cross multiply, guys. I could. But do you want to multiply 18 times 18 and 12 times 27 to see if they're equal? Not me. Okay, 27? 9, so I get what?
Oh, 3 over 2.
3 over 2. So, are they similar?
Yes.
Yes. Questions? Okay, so now we have two questions. You have a left-hand question and a... So I want to know if these two triangles are similar, and then I want to know if
Those 2.
those two are similar. Do you see how I have each side of your picture on your paper?
Yeah.
Okay, so we have ADE, so triangle ADE, and writing it like this, guys, will help you. It really will, I promise. Over a triangle ABD. Okay, so that's which triangles? This triangle and
And the
Big center one.
big one.
and the big one. Yes?
Yeah.
Okay. So ADE is the little one. So we got, what similarities are we going to use? Side, angle, side, or side, side, side,
Side angle side.
or side, angle, side?
Side, side, side.
Side, side, side. Why side, side, side?
Because they all have
Oh.
all 3 sides.
We all have, but they don't have a, they do not have an angle that's congruent, do they?
No.
No. They don't have an angle congruent, but we do know all 3 sides, yes? Okay, so the only thing that's going to work is side, side, side. So ADE is the little one. So we want 1.8, 1.8, and
2.4.
2.4. Okay, so what corresponds to 1.8?
2.4.
2.4, 2.4,
3.2.
and 3.2. Now, does everyone just see 18, 24, and 32?
Yeah.
Does everyone see that up there, basically?
Yeah.
Are we good with that? Josh? Are you sure? Okay, so we're just going to reduce them like we're looking at 18, 24, and 32. All we have to do is multiply everything by 10, right?
Yeah.
So we're good. Okay, 18 and 24, what's it reduced by?
4.
Bigger. And 4 doesn't go to 18.
6.
6? So 3/4? Well, the next one better be 3/4, right? And what about 24 and 32?
12.
No,
8.
8. 12 times 3 is 36. Okay, so if they were reduced by 8, what do I get?
3/4.
3/4. So are they similar?
Yes.
Yes. And you know what? We should have been putting, they are similar. How? We should have been putting what? Side, side, side similarity, huh? So what was the first one?
The first one was side, side, side.
Side, side, side similarity. So go back and add that to your first example. I was bad, wasn't I? What about the second one?
Side angle side.
Side, angle, side. So go back and do your side, angle, side similarity. Sorry, guys. Okay, now which two triangles are we going to do?
ADE and BBC.
So we're going to do triangle ADE. So that's this one, right?
Yeah.
Okay. And ABC or BDC. My PowerPoint doesn't have C on it for some reason. Okay. So here. So what rule, if they are, is going to work on this one?
Side angle side.
Side, angle, side. How do you know it's side, angle, side?
Because BDC only has two sides and one angle,
Right.
and then they mirror each other.
Right. They both have an angle congruent, yes. And BDC doesn't have a third side, so I can't use side, side, side. Everyone following?
Yeah.
So if it works, it's going to be side, angle, side. So we don't have to do 3 ratios. We only have to do 2. Okay, so ADE. So what 2 sides are we going to be looking at?
2.4 and 1.8.
Okay, so 2.4 and 1.8. So what corresponds in BDC to 2.4?
2.4.
2.4. Now what corresponds to 1.8?
1.4.
1.4. We already know, you all should be going, nope, don't work. Why?
Because
it's
2.4.
Because this is 1 over
That's
1. And 1.8 over 1.4 is not
1 over 1.
1 over 1. Okay, so this would be 18 over 14, yes? What is 18 over 14 reduced to?
Probably like
9/7.
Yeah.
Is 1 over 1 equal to 9/7?
No.
So we just make that equal sign, and what do we put across it? Slash, not equal, so they are not similar. Have I explained why they're not similar?
Yeah, because they're not equal.
Right. Those don't equal. Questions? Yes.
Should you say, like, how you figured out they weren't similar?
Well, you have your ratios up there. So you're saying by side, angle, side similarity?
Yeah.
If you want to, you can, but you don't really need to because because if they're similar, the ratios are equal. They are proportional. So since they're not proportional, they're not equal, then they're not similar.
Okay.
Okay? Any other questions? Jacob, are you awake?
Yeah.
Okay. So we got some questions here. Nope. Yes. Yes. Okay. What is MN?
A line.
No, what is
It
it?
is MN.
Mm-hmm.
Uh,
So we're obviously going to use similarity rules, right?
Yeah.
Which similarity rule would we be using?
Starting with
Side angle side. Why?
Because
don't have
L is
sides.
congruent in both.
Yeah.
Why?
Because they're.
Thank you. They're vertical, right? They don't have to put these lines there because do we know that those are congruent? Yes. If you can write on your paper, should you put them there so you see it?
Yeah.
Yep. Okay, so if it is, it's going to be side angle side, right?
Yeah.
Okay. So then, can I just put an X here?
Yeah.
Okay. So X and 1. So what corresponds with X?
10,
10. And what corresponds with 1?
75.
75. So I multiply by 10.
Yeah.
So what goes into 10 and 75?
5.
5. So I get 2 and 15.
Yes.
So 2 15ths. Okay. So now we have some questions we got to think about a little bit. It's kind of hard. If the measure of JL were 150, how would the value of MN be different? So in the x over 10 equals 1 over 75, what value would change to 150?
The 10.
It'd be-
No,
No, it'd be the 75.
It'd be the 75.
If JL
So that would make JL 150, so it'd be x over, here, all right, x over
30.
10
2 over 30.
equals 1 over 150. What's going to happen to the side length?
It'd be
It'd be a lot longer.
Really?
2 over 30.
No, it wouldn't.
Some shorter
It'd be shorter
because it's a bigger number.
Oh.
because I'm dividing it not by 75, but what? 150. 150 is twice as big as 75, isn't it?
Yeah.
So did that made the side half, didn't it?
Mhm.
Because if I divide by a number that's twice as big, is it going to make the end result half of what it was? Right. So what did it do? It made it half as long. Okay. So what's going to happen if I made JK 20?
The 10 would change.
So it'd be x over 20 equals 1 over 75. So I'm not dividing, I'm what?
You're
Multiplying.
So it'll be 20 over 75.
So that would be 4 over 15.
Yeah.
Yeah. So
So that one
So it made it
bigger.
bigger.
how
Twice
much?
as big.
It made it twice as long. So does it depend where the number falls on what it's going to do to it?
Yes.
Yes.
Blaze?
Yeah,
He's awake.
No. Eyes open.
no, I'm awake.
But eyes open.
My eyes.
Okay. So don't just automatically assume that it was twice as big, so it's going to be twice as big. Because that's not going to happen all the time, is it? Okay. Questions, guys? Are we good?
Yeah.
Okay.